All right, this video is the introduction to the normal distribution. Now, we have talked about skewness and symmetry so far already, and we have three graphs here, and you can see that this one is skewed left, right, because the data tails off to the left. This one is skewed right because the data tails to the right, and this one, which is down, up, down, this, the unclear pattern, this is nothing. It's not symmetry, it's not skewed right, it's not skewed left, it's just random data, right? And you're like, well, I don't know what this has to do with anything. Well, every once in a while, we do have symmetry. And if we have symmetry, then we have we can have the normal distribution. So the normal distribution is often referred to as the bell-shaped curve because it looks like a bell. And obviously, very few things, if anything, is exactly symmetrical. So we would say it's approximately normal if we have the basic symmetrical shape. Now, characteristics of the normal distribution, the mean, the median, the mode are all the same, and they all fall directly in the middle. Because it's symmetrical, each side is the same, and you get 50% of your data on each side. All the area under the curve, this whole thing, right, is 100%. It's all of your data. Now, technically, these things never touch. They just go on and on and on forever because you have the potential to be, really far out on either end. The probability is just very close to zero. Also, all of the area under the curve, all of this, we can talk about in terms of probability, which we do have a video on that here soon. So let's do some problems with this. Here we have birth weights, the distribution. Excuse me. Here you see n equals 3,226. N is the sample size. So we have 3,226 birth weights of babies. Excuse me. This question talks about the height of the bars. What do the height of the bars represent? Well, that's frequency. And what is frequency? Well, it's the number of babies with that particular weight, right? Frequency is the number of, and in this case, birth weights. Number two, what do the widths of the bars represent? So if you'll notice, this is not just a single line. There is a width to it. So the width is kind of the range of birth weights. So in this case, I don't think it's nice and, perfect. But you'll see, let me get this orange spot, halfway between there's a little dot in there, and that makes it 2.5. So each one of these might be 2 to maybe 2.15 or 2.17, something like that. So the bar would be anything between like 2 and 2.15. I'm just estimating what this would be. But the width of the bar represents this whole range of birth weights. So any baby that fell within this birth weight would be within that bar. That's what they're talking about. Would you say the bell-shaped curve is skewed or symmetrical? Well, the fact that it's bell-shaped implies symmetry. So you can only have the normal distribution or a bell-shaped curve if you have symmetrical data or approximately symmetrical data. Number four, what is meant by the distribution of birth weights? Well, distribution, it's kind of like how spread out they are. How spread out the birth weights are, from here to here, that would be kind of like the distribution. The range, the smallest to the biggest, anything kind of dealing with that. All right, and let's go more into the distribution of the weights. You see three curves here. We have three cities, Austin, Indianapolis, and San Diego, and they all have normal distribution curves. And I just answered number one because you see they have the bell curve on them and they're all approximately normal. But they are all a little bit different. So let's talk about these. How are they the same? How are they different? Well, knowing what we know about the normal curve, we know that right down the middle of each one is the mean. And if you look at that, they all have the same mean. And that's true because that has to be true if they're all a normal distribution curve. Now, how are they different? Well, hopefully just by looking, you can notice that, Indianapolis is short and really spread out. San Diego is a lot taller and a little bit thinner. And Austin is kind of halfway between them. So they're different in terms of the shape of the bell curve, in terms of either short, tall, skinny, spread out, that kind of thing. So we're going to rank these cities in terms of temperature variability, which has the most variation and which has the least. Well, the most variation would be Indianapolis because it's the most spread out, right? So Indy's the most spread out. Then I would say Austin, and San Diego has the least variation because it's grouped really close there into the center. So when it comes to standard deviation, the more variability, the more spread out it is, the higher the standard deviation. So Indy would have the biggest standard deviation, Austin would have the middle standard deviation, and San Diego would have the smallest standard deviation. So when you're looking at data, if it's short and really spread out, that's going to lead to a larger standard deviation. High and tight, smaller. So the more closely rated your data is, the smaller the standard deviation. All right, let's look at these two problems. Well, it's not, I guess not, there's three of them technically. We have the spring semester and the fall semester. Spring noted by the high and tight solid line, while the fall semester is low and wide, the dotted line. So which one appears to have a slower or a smaller standard deviation? Remember, standard deviation talks about the distribution. The wider the distribution, the larger the standard deviation. So you can see that this, the fall, has a wide distribution, which means higher standard deviation. The spring is high and tight, smaller variation, smaller standard deviation. So who has the lower? That would be spring because it's high and tight. Number 5, in which semester did students receive more Fs? Well, Fs is anything below a 60. I'm going on our grading scale here. So you can see that underneath the dotted line has more air or more space than under the solid line, and therefore fall semester received the most Fs. And where were more Cs earned? Well, Cs are from 70 to 80. So if you look at this, we have, this is, spring wins here, fall wins here. Which one of those do you think is, more? I vote that this one is bigger, so I think spring earned more Cs based off of this. But it looks like, this isn't a question, but it looks like fall earned more Bs and above, just based off the space there. So that's kind of your introduction to the normal distribution and the mean standard deviation, how it all fits.